Welcome to Crack It YouTube channel. Today we are going to discuss a very important topic, how HashMap works in Java. Let's go to the question. So first of all, what is a HashMap? HashMap is nothing but a data structure that is used to store a key and a value pair. And if you want to retrieve the value, we need to use that key. Internally, this key and the value are stored as a map.entry instances, which is represented as a node. Let's see this in a Java code. So this key and value pair are stored as a map.entry instances, and this map.entry is represented as a node as we discussed. And in a node we have a hash, key, value and next. Hash is nothing but the hash code of the key. This is the key of the map and this is the value which we need to store, and we use this next pointer to store the next node. How HashMap works? HashMap has a key and a value pair which it needs to store. So HashMap always stores its key and value pair in a bucket. What is bucket now? Buckets is nothing but the array of nodes. This is from the Java code. Here we can see that the array of this nodes is called as a bucket. So single bucket is an instance of a single node class. Each node is a data structure similar to a linked list or a tree map. So HashMap always stores its key and value pair in a bucket. So how will it know in which location it needs to store in that bucket? To identify that, HashMap uses its key to create a hash value. So what is a hash value? How to create this hash value? HashMap uses this principle called hashing. Hashing is nothing but creating a unique code for the object. Now HashMap will create a unique value for this key using some function or the algorithm. We have a separate video for hash code and equals contract. I'll pin that in the comment section. You can go and view it if you need it. So two equal objects must consistently produce the same hash code. So the entire functionality of this hash map is mainly relied on this hash of its key. So Java produces one more layer of hashing to evenly distribute this hash code. This is the hash function from the Java code. So if we see in the code, we have key.hashcode method. So this key.hashcode method is the user implemented method, but there is a chance that this user implemented method may not produce evenly distributed hash codes. So Java adds one more layer for this hashing to make it distributed reasonably. Now let's discuss about the internal implementation of the HashMap. HashMap is nothing but a hash table based implementation of the map interface. What is hash table based implementation? It internally maintains an array, and that array is called as the bucket array, and the size of this array is the initial capacity of the hash map. As per our Java doc, the initial capacity of the map is 16. This is the HashMap class from Java, and we can see that the default initial capacity of the HashMap is 16. Let's see how HashMap.put operation works. This is the put method from the HashMap class. The put API internally first calculates the initial hash using the key.hashcode method and then calculates the final hash using this hash method. Hash value that is returned from this method is used to calculate the index of the array or the bucket location. What is collision and how is it resolved? Let's see this with an example, then let's go through this slide for better understanding. Let's now recollect what bucket is. The instances of the node class are stored in the array. Each index location in the array is treated as a bucket. For example, 0th index is treated as a bucket. Let's assume hashing algorithm as key %10 in our example. So when a node object needs to be stored in a specified index, HashMap will check the index of the array. If the index is empty, or if there is no node present in the index, the current node is stored in that location. So if we see in this example, the key is 100. 100% is 0. So it should be stored in the 0th location. If this node comes to the 0th location, it will see whether it is empty or not. Yes, it is empty. Then this current node will be stored in the 0th location. Our next value is 2. 2%10 is again 2. It needs to be stored in the second index of the bucket, it will check whether an element is already present. No, it is not present. So this current node will be stored in the second location. Suppose if our next value is 12. Now 12 percentile 10, again it is 2, it will come, check in the second index, it is now able to see an element here. If it sees an element, it will check whether this is a tree node or a linked list node. In our case, it is a linked list node. In case of linked list node, it will check the next pointer. If the next pointer is null, then it will place this current node as its next node. Let's discuss this theory now. When a node object needs to be stored in a specific index, HashMap will check the index of the array. If the index is empty, then the current node is stored in the location. In our case, for the first element, the index was empty, so the current node was directly stored in that location. If there is an object already present in the specified index, suppose in our example, if for the key value 12, it comes to the second location and the second location was full, then the HashMap will check whether it is a tree instance or a linked list instance. In our case, it was a linked list instance. So if this is a linked list instance, the next attribute of the node is checked. If the next attribute is not null, then the process is followed until the next is evaluated as null. In our case, the next pointer was null, so we place the current node in the same position. While iterating the nodes, if the keys of the current node and the new node are equal, then the value of the current node will be replaced by the value of the new node. We will understand this now with an example. This is a hash map and our next node is with a key 2 and a value crack it. What will happen in this situation? In this situation, if there already exists a key with the same hash code, then the equals method is used on the keys. So 2 will produce the same hash code. So equals method is called, and in the equals value, the equals method will now return true. If the equals method return true, that means there is already a node with the same key. Yes, we have already a node with 2 as the key, and hence the value against that key is overwritten. So the value is changed from crackit 1 to crackit in our case. There was a performance improvement in HashMap from Java 8. What is that? HashMap replaces the linked list with a binary tree. When it will replace? When the number of elements in the bucket reaches a threshold. What is the threshold value? That is 8, and it is called a tree-fi threshold. So in a bucket, if the number of nodes is 7, it will remain as a linked list, and when it reaches 8, suppose if the 8th element comes, that linked list will convert to a binary tree. How will it get converted to a binary tree? What are the parameters that will use? That will use the hash code as the branching variable. If there are two different hash codes in the same bucket, then one is considered as bigger and goes to the right side of the tree, and the other one is considered as smaller and that will go to the left side of the tree. But when both the hash codes are equal, HashMap assumes that the keys are comparable and compares the value of the key to determine the direction. So it is always a good practice to make the HashMap keys comparable. Because of this conversion from linked list to binary tree, the performance has been improved from order of n to order of log n. So there was a memory overhead when the linked list is converted to a binary tree. Will it remain as a binary tree even though the elements is removed? No, it is not the case. When the nodes in the bucket reduce less than the untree-fi threshold, which is 6. When the nodes in the bucket reduces to 6, then the tree again converts to the linked list. This will help to balance the performance with the memory usage. Why? Because tree nodes take more memory than map.entry instances. Tree will be used only when there is a considerable performance gain in exchange for memory wastage. Let's see this with an example. Here in our example, in the 6th index, we can see that 7 nodes are already present. So what will happen if a 8th node comes? We have this tree-fi threshold as 8. So ideally, if the 8th node comes, then all these nodes must be converted into a tree. With this, we come to the end of the put API. What will happen if HashMap.get operation is called? When the get method is called with a key, then its associated value should be returned. The way to find the bucket location for the get is same as that of the put API. Once the bucket is located using the final hash value, then the first node at the index location is checked. This is the get method of the hash map. Once the bucket is located using the final hash value, the first node at the index location is checked. If the first node is matching, then it will return the first node. If the first node is not matching, then it will check whether the first instance is a tree node. If it is a tree node, then it will call the tree node API to search the keys. If it is not a tree node, then it is a linked list. It will search using the linked list fashion. What is the linked list fashion? The next attribute is checked in each iteration until the matching key is found for the node. We just covered these 2 points using the Java code. So if the first node is a tree node, then the corresponding tree node API is called. If the first node is not a tree node, then the corresponding linked list API is called for the search. In HashMap, we have another interesting topic called rehashing. I'll cover this in a separate video. Thanks for watching Crack It. Please do like, share and subscribe.